everyone. In today's brief video lecture, we are going to be covering cross-tabulations and correlations. And we want to use a cross-tabulation anytime we are looking at the relationship between two categorical variables. And those categorical variables can either be dichotomous, such as yes-no responses, or kind of pure categorical variables such as race, where the numbers attached do not denote any value-based difference. So for our example, what we are going to be looking at are the relationship between two variables that were measured on a binary or dichotomous scale, where 1 for each variable indicates a no and 2 for each variable indicates a yes. And the two variables we are looking at to see the relationship between are whether or not someone smokes and whether or not they also have heart disease. So here our data table is represented by an ID for each person and then a value for whether they smoke and whether they have heart disease. Now the first thing that we want to do is to do a custom sort to where all the people who indicated a 1-1 are paired together and all the people who indicated a 1-2 are paired, 2-1 and 2-2, etc. And what we are going to be doing is populating this contingency table that you have to create, which is essentially a count or a frequency for all the different response possibilities that we have in our two variables. So to do a custom sort, you'll want to click on the Home tab in Excel, go to Sort and Filter, and request to do a custom sort. And here we will want to sort by the smoke variable as well as the heart disease variable. We click OK, and now as you can see, all the people who indicated that they did not smoke and did not have heart disease are together, as well as all the remaining variables. People who indicated a 1 and 2, a 2 and 1, and then a 2 and 2. And then what we'll want to go to is our contingency table. And here we'll start with all the people who indicated a 1 and a 1. And how you do this, I think the easiest way to do it is enter an equation equals count. And then in parentheses, what you'll want to do is just click and drag down in one column the total number of people who indicated a 1 and a 1. We'll end it there. We'll close our parentheses and hit return. And this simply counts the total number of cells that we have identified. So there's 64 people who put a 1 and a 1 or indicated that they did not smoke and did not have heart disease. Next, we'll go to the people who indicated that they did not smoke but had heart disease. So we'll do another equal count, and in parentheses, we will click and drag on all the people who indicated both a 1 and a 2. And that stops right there. We will close our parenthesis and hit return. And here we can see that 36 people indicated that they did not smoke but had heart disease. Next, we'll go to the people who indicated that they smoked and had heart disease and repeat the equation equals count. These are people who had a 2 for smoke and a 1 for heart disease. So we'll start right here. We'll click and drag down all the 2 1s. Close our parenthesis, hit return or enter. And we'll see that there's 27 people who did not have heart disease but did smoke. And then we'll do our final count of all the people who put that they both smoked and had heart disease. So these are all the people I indicated a 2 and a 2. We'll close our parenthesis, hit enter. And now we have the counts for all the people who indicated all the different possible response categories. Now to finish our contingency table, what we want to do is calculate our row totals, our column totals, and then this bottom right diagonal cell right here, we'll want to calculate the total n of our sample. So for our row totals, what we want to do is an equal sum, and then we'll want to include the cells for all the people who smoked. And here we'll do the same, equal sum, all the people who did not smoke. And then for our column totals, we'll want to sum all of the people who had heart disease. And then here we will want to sum all of the people who did not have heart disease. And lastly, for our total number of people in the sample, we'll want to sum all of our response cells here together. And we can see that we have a total number of 200 people in our sample. Now, the next table you want to create is this observed and expected table. And observed is the most straightforward. Here we're just reorganizing the information that we have in our contingency table. So for all the people who smoked and had heart disease, here we can see in the yes, yes column, we'll want to indicate 73 here. For all the people who smoked but did not have heart disease, we have 27, which we can indicate here. For the people who did not smoke but had heart disease, there were 36. And for the people who did not smoke and did not have heart disease, there are 64. Now, to calculate the expected values, essentially in crosstabs and chi-square tests, the expected values are the values we could expect if there were absolutely no relationship between smoking and heart disease. Okay, and what we're essentially doing in our test is looking at our observed values relative to the expected values, and we're seeing if the observed deviates from the expected enough so that did we get a significant p-value, which would indicate that there is in fact a relationship between smoking and heart disease. So here I've copied and pasted the formula to calculate expected values from the accompanying Word document. And essentially what you want to do is enter in an equation where we're multiplying the column total and the row total for that specific response and then dividing that multiplication by the total number of people in the sample. So to begin with here, we want to look at the row total and column total for all the people who indicated yes, they smoked, and yes, they had heart disease. So we're focusing on this cell right here, which is J5, and we're multiplying J5's row total, which is 100, by J5's column total, which is 109. And then we're dividing this by the total number of people in the sample, which is 200. Okay, so here, just doing the eye test, we can see that our observed value of 73 is almost 150% larger than our expected value of 54.5. So it's kind of a prelude to see that, okay, it looks like even from this first computation that there is a significant relationship between smoking and heart disease. And then what we want to do is go through for each of our response categories and duplicate this process. So for the people who indicated that they smoked and did not have heart disease, we're going to be focusing on this cell right here, K5, and multiplying the row total, which is 100, by the column total for no, which is 91. And then dividing this by 200. And that's the expected value of people where if there was no relationship whatsoever between smoking and heart disease, given these row total and column total counts, we should expect this number to be 45.5. The actual number is just above or just under half. Okay, now we're replicating this for our final two response options. Here we're multiplying the column total by the row total. So for the persons who did not smoke and did not have heart disease, that's did not smoke and did not have heart disease, we're focusing on K6 right here. Our column total is going to be 91, and we're multiplying that by 100, which is our row total, and dividing by 200. And as you can guess, chances are the final value here for no might be similar to this 54.5, but we're going to calculate it, and we're going to take our column total here, which is 91, multiply that by 100, and then divide that by 200. And if we were to guess, we would have guessed wrong, unfortunately. Sorry. So essentially here, again, what we're doing is we're taking the column totals. Actually, let me verify this. Okay, so very good. Okay. Right here, I made a little typo. And it was a little bit more than a typo. For heart disease, yes, I actually used the wrong column total for no. So we should have gotten two basically matching expected values here. So I used 91 instead of 109. Okay, so very important to check your work here. So we're going to equal in parentheses the column total for persons who did not smoke but had heart disease. That's J6 right here. The column total is 109. We want to multiply this by 100 and divide by 200. Okay, and now we have our observed and our expected values. Now, in order to calculate the chi-square test statistic to see if there is a relationship between two variables, you have to do a little bit more than you'd have to do in the other tests, and I'll show you why in a second. To get the actual p-value, all you have to do is enter in the equation equals chi-square test. So chi-square dot test, and then the actual range we're going to put our observed values, and then in the expected range we're going to put our expected values. Close the parenthesis, hit enter. That gives us a p-value. But what the chi-square test does not do in the data analysis tool pack is actually give us the chi-square test statistic. So we have to calculate that by hand. But this right here is the p-value. And if we're using the traditional 0.05 level, we can see that this is highly, highly significant. It is far lower than the 0.05 probability value. So you could put something like p is less than 0.001 or 0.0001 when you're reporting these results in APA. But to get the actual test statistic, we have to do this manually by hand. And the formula for doing this is we're going to take the observed value, which is 73, and then we're going to subtract the expected value from that, take the square root, close parenthesis, and then divide by the expected value. Hit enter. That will give us a 6. And here we can use the magic button to go down and calculate this for each one of our values here. And you can double check to make sure that the right cells are calculated. But those will give us essentially what we need to calculate this chi-square test statistic. And that test statistic is simply the sum of all of these equations here. So we'll add all those together, and there we have a chi-square test statistic of 27.6. So if we were reporting this, at least for the inferential test, the chi-square test and the p-value, we would state something like there was a significant relationship between smoking and heart disease. And then we would put chi-square n equals 200 equals 27.60, comma, probability less than 0.0001. Okay, and that about covers it for crosstabs and chi-squares. So definitely if you have any questions around these equations, be sure to refer to the the Class 8 handout, which kind of goes through all of these step by step and how to calculate these and how to report these in APA format. But then also feel free to reach out to me. I'm happy to answer any questions you have via email. Now, the correlation is a lot more straightforward. Okay, so here, what we want to do is go to data, go to our data analysis, select correlation, and then for our input range, we'll want to highlight the values on our two variables we're looking at the relationship between, which in this example are height in inches and weight in pounds. Output this correlation table here and click OK. And here you can fill in, height, weight, and this is a correlation matrix, and this value right here is what we're most interested in. This is the actual correlation. So we're looking at the relationship between height and weight and seeing that that R value, or correlation value, can be rounded up to be 0.83. Now, when you report correlations, you generally report the correlation, you report the total number of people in the sample, or the N, and then you report the test statistic, degree of freedom, and the probability value. Okay, so for our N, we can see just from looking at the ID that we have 16 people in this sample. And the test statistic is kind of a complex equation, but I have put it here in the table, and it's also explained in the Word document. And I don't think it is very helpful to go through explaining why this is the way it is, because it's fairly complex. But here, I think it's best just to enter in the equation and double check to make sure that you entered it in right. So here, we're multiplying the correlation by the square root of n minus 2, which is 16 minus 2. We're closing all of our parentheses here, and then we're dividing this by the square root of 1 minus correlation squared. And that's our equation. We're hitting enter. Chances are I did not close a parenthesis, so I'll make this correction. And there's our test statistic. It's 5.57. And our degrees of freedom, I'm going to refer to the Word document here. How we calculate our degree of freedom is that we take the N and we subtract it by 2. Okay, so that is going to be 16 minus 2, which is going to be 14. And then how we get the p-value is we're going to use this formula t-dist, and we're going to include the test statistic value, the degree of freedom, and the number of variables we're looking at, which is 2. So what I'm going to do now, so you guys can have all this information in one place, is copy and paste this into the Excel file. So here for our p-value, we're going to hit enter, t-dist. In parentheses, we're going to put our test statistic, which is 5.5679. Our degree of freedom, which is 14, and then the number of variables we're comparing to. Hit enter. And here we talked a little bit about this last time, but a lot of you, when we're doing these test statistics with the p-value, you'll get this odd e minus 0.05 number. What you can do here is right-click, format cells, make this a number, and then change the number of decimal places until we can actually see what this number is. You might have to widen the columns to actually see the number. But here we see that it is very, very significant. So here it's p is less than 0.0001. That's our p-value. And then in the Word document, I also give some indications of how you report this. So what we would say is that there was significant correlation between height and weight. R is the correlation with 14 degrees of freedom equals 0.83, and probability is less than 0.001. And really there's multiple ways to report this. We could probably add an extra zero in there. Sometimes you can go to the 10th, 100,000th, 10,000th place. But in other instances, you may only want to report to the 1,000th place. But either way, we can see that there is a significant positive correlation between height and weight. So you definitely always want to specify the direction, whether it is positive or negative. Okay, and the last thing I'll show you, and this is just kind of a bonus tidbit, is if you wanted to look at this relationship, what you could do is insert a scatter plot. Oh, I think it wanted us to select our data first. So if you select height and weight, and then insert scatter plot. Here you can see that there is a positive relationship between height here and between weight here. You can see the trend line, if we were to put one in there, shows that there is a positive relationship between the two variables. And that's it for today.